In solving parts of determinants, it is possible to skip some parts of the procedure. Check out how here in Numerical Solutions 2C problems. Given the 4 by 4 matrix, we are tasked to look for parts of the determinant in different methods. First is through Trio's pivotal condensation, where we should identify elements 2, 3, and 3, 2 of the resulting 3 by 3 matrix. Second is the determination of the second and third terms when we are using Gibbon's rule. The third task is to look for the second and third terms of the process when using Laplace cofactor expansion method with column 2 as the pivot column. The first task demands the use of Trio's pivotal condensation method. The condition in using this strategy is to look for an element valued at positive 1, and in the matrix, that would be element 2, 3. By covering the row and column intersecting element 2, 3, the other remaining elements can be taken as the first elements of the 3 by 3 matrix. The next step is to subtract the reflected factors from the covered row and column. For element 1, 1, we subtract 3 by negative 2. Element 2, 1 is subtracted by 3 times 3. The element below it is subtracted by 3 times negative 4. For the second column, the element on top is modified by negative 5 times negative 2. The next one below is subtracted by 5 times 3. Then the element at the bottom is reduced by 5 times negative 4. The last column on the right starts with 4 minus 3 times negative 2. The next element is lessened by 3 times 3. And the last element is subtracted by 3 times negative 4. Simplify each term and get the resulting 3 by 3 matrix. Don't forget that there's still a negative 1 scalar to be multiplied to all elements. Thus, element 3, 2 is negative 25, and element 2, 3 is positive 13. Check the previous videos on how to identify the reflected factors. The next task is to look for the second and third term values when using Gibbon's rule. Recall that the second term of this method has columns 2, 3, and 4 rotated. After the columns are arranged, mirror the 3 columns and then proceed to extended Sarris rule. The first positive has 2 times 1 times negative 4 times 5, which is negative 40. The next positive has negative 2, 3, 6, and 4, resulting to negative 144. The third has 4, 5, negative 2, and negative 4, giving out positive 160. Then the last positive has negative 3 times 3 with another 3 and 6, which gives negative 162. Before adding these values, remember to have the sign change starting with positive. So negative 40 minus negative 144 plus 160 minus negative 162 is equal to 426. Now solve for the negatives. The first of which is 4 times 3 times 3 times negative 3, giving negative 108. The second has negative 4 times negative 4 times 5 times 2, which results to 160. The third negative is 6 times 6 times 3 times negative 2, which is negative 216. The fourth anti-diagonal has 5 times negative 2 times 1 times 4, giving negative 40. The sign flip for negatives start with negative. So we have negative of negative 108 plus 160 minus negative 216 plus negative 40, which is equal to 444. Finally, 426 minus 444 makes the second term as negative 18. Moving on to the third term. Another rotation of the latter columns is made, so after the first column, the fourth column follows. Reflect the 3 columns before multiplying elements in diagonals. The first has 2, 3, 6, and negative 4, which are multiplied to negative 144. The next has 4, 5, 3, and 4, which are multiplied to 240. The third diagonal has negative 3, 1, negative 2, and 6, giving 36. And the last has negative 2, 3, negative 4, and 5, which are multiplied to 120. The positives flip signs starting with positive. The positive is then taken from negative 144 minus 240 plus 36 minus 120, giving negative 468. The anti-diagonals start with 4, negative 4, 5, and negative 2, giving 160. The next is 6, 6, 1, and 2, which makes 72. The third has 5, 3, 3, and 4, resulting to 180. Then the last anti-diagonal has negative 4, negative 2, 3, and negative 3, giving negative 72. Flip signs starting with negative, then add them. That's negative 160 plus 72 minus 180 plus negative 72, which is equal to negative 340. Subtract positives with negatives and get negative 468 minus negative 340, resulting to negative 128. The third task focuses on column 2 as pivot for Laplace cofactor expansion method. When solving for the second term, cover the second row and extract out 5. But don't forget the sign flip where 5 will be taking a positive sign. The remaining elements create a 3 by 3 matrix, which makes it possible to use Sarri's method. By taking diagonals minus the anti-diagonals, the determinant of the small matrix is negative 4. So 5 times negative 4 gives the second term as negative 20. For the third term, cover the third row and extend the sign flip. The remaining elements then make the smaller matrix with negative 6 as a scalar. By using Sarri's rule, multiply elements in diagonals and also anti-diagonals, giving negative 6 of negative 16. This results to the third term of the method as positive 96.